Hello and welcome to PAAcademy. So in this video, we are going to be looking at DFT, which is Discrete Fourier Transform. Alright, so to start with, we are not going to be going through the process of defining what DFT is and everything, but the main focus here is how to answer questions that has to do with DFT, which is the Discrete Fourier Transform. So now let's start with the formula for DFT. So the formula is giving us x of k. So it's going to be capital X. So x of k equals to summation of n equals to 0 with capital N minus 1 at the top. Then x of n exponential minus j pi k2n over small n. So all this here, this like this, is more like a power to the exponential. So that's just the formula for it, and we're going to look at one example now, and with that example we'll be able to understand how to apply the formula. Although this is the formula that we're going to be using, but you might just come across another formula looking like this, which can also be rewritten as the summation of capital N here minus 1 with n equals to 0 of x of n, then w is to power kn, and then capital N here. Alright, so however, for this we are going to be making use of the first one. So I only wrote this so that in case you come across it somewhere else, you should know that they are still the same thing, but the application might just be a little different. So now let's look at one example so that we can use it to explain the formula. So let me Alright, so let's look at this example together. So that's for the A part. So it says given a sequence. So it says given a sequence x of n for 0 is less than n greater than, for 0 is less than n less than or equals to 3, where x of 0 is 4, x of 1 is 3, x of 2 is 2, x of 3 is 1. Compute its DFT. So you can see it's just a question with just 2 lines. That's for the A parts. Now let's pick out some of the important information that we actually need from the question. So from the question, we are told that for our x of n ranges from 0 less than or equals to n and less than or equals to 3. So what that means is that our n is from, so what this actually means is, that means from 0 to 3, we are going to have 0, 1, 2, 3. Exactly. So that means we are having, this is 1, 2, 3, 4. So that means our n, which is our capital N, which is this here, is 4. Exactly. So that means our n is equals to 4. Also, for us to get the value of this k, our k, so k is n minus 1. So that means our k will be 4 minus 1, which is equals to 3. So since it is 3, that means our k will start from 0, because the value of k always starts from 0. Alright, so our k will be 0, 1, 2, 3. So take note of this. Then so now let's write out our x of 0, x of 1, and x of 3 like that. So from the question, we are given that our x of 0 is 4, because we are going to need these values. Our x of 1, so what's our x of 1? Alright, so our x of 1 is 3. So x of 1 is equals to 3. And our x of 2 is equals to 2. And then our x of 3 is equals to 1. Alright, so now let's bring back our DFT formula again. So again, our DFT formula is x of k, don't forget it's a capital X. So now we can put in some of those values with what we have there. So we know that our n is already 4. So that means what we are going to be having here will just be 3. And then we already know that our n is also 4, and then we have 2 here. So let's rewrite it in putting some of those values that we already have now. So that's summation n equals to 0, then 3 x of n exponential minus j k 2 pi n over. Now we can go ahead and write 4. So if you look at it closely, there is 2 here, there's 4 here, so this can cancel this, and then we'll have 2. Okay, so just take note of that. Alright, so now we can also continue with having x of k equals to the summation with 3 n equals to 0 of x of 0. Now we are bringing in the x of 0, x of 1, x of 2. You can see we are replacing, putting it in place of this x of n. So x of 0 exponential. So x of 0 exponential. Now between this x of n and this e, there is more like a multiplication here. So take note of that. So x of 0 exponential. Now this n, that means n here at this point is 0. Exactly. So the same n here, if you should bring it here, is the same n that will be here. I hope you get that. Now, once we use it to multiply everything that is here, we are going to be left with exponential minus j. So we'll be left with exponential minus j. Are we good? So now let's continue then, plus x of 1 exponential. Now our n, this particular n, this n here is now 1. So if this n is 1, so we are going to be having minus j multiplied by k multiplied by pi. So that would give us minus j k, and then remember we're having 2 here. This pi, you know that pi itself is 180 degrees. Exactly. And we are having 2 here. That will be over 2. That's 90. So to make our work much easier and more understandable, so I can go ahead and put 90 degrees here. Are we good? So let's continue. So plus x of 2 exponential. Now our n is 2. So that means this n here is now 2. So what do we do? So since our n here is 2, since the n is already 2, that means this n, let me just write it again. So that means this n is already 2 for x of 2. It can cancel this 2 that we have at the denominator. So if you are to write it, we'll be left with minus j, k, and then pi. That's this pi. So our pi is 180. So let's go ahead and just write it 180 degrees. Then plus x of 3. So x of 3, now that means our n is 3. So if our n is 3, that will be exponential minus j k. So since this n is 3, so let's just multiply it with the value of pi, which is 180, and divide it by 2. So what we are going to be having is 180 times 3 divided by 2. So that's 90 times 3, and that should give us 270. So 270 here. All right. So the next thing we are going to do is we are going to be putting in the value of k in what we have in this last line. But now let's go back to the question. Like here, we've already established that the value of k is 0, 1, 2, and 3. So now let's come here and say when k is equals to 0. So that means we are having x of 0 is equals to, so let me just omit this here. So you can go ahead and write this first one since there is no k there. So let's just write it back. So that's x of 0 exponential minus j plus x of 1 exponential. Now for this, we already know that k is 0. So, and since the value of k is 0, that means what we are going to be having here is just exponential minus g. Exactly. Because of k is 0 here. So plus x of 2 exponential. So the same thing will happen here. Since our k, this k is 0, we are going to be having exponential minus j. Then plus x of 3 exponential. The same thing, our k is 0, so it will just cancel out to what we are having here, giving us leaving us with exponential minus j. All right, so now let's tidy this up. Now our x of 0, and don't forget I said as we're having x of 0 exponential, before the exponential we are having more like a multiplication here, a multiplication, even though we are not writing it, there are multiplication here. So let's go back. Our x of 0 from the question, so you can see here, our x of 0 is 4, x of 1 is 3, x of 2 is 2, x of 3 is 1. So those values, we are going to be substituting them. All right, so our x of 0 is 4, so that will be 4 times. Now exponential minus j is 1, exactly, so that's 1, plus, now x of 1 is 3, right? Yeah, this is it. X of 1 is 3. So that's 3 times, again, exponential minus j is 1, plus x of 2, our x of 2 is 2. So that will be 2 times exponential minus j is 1, plus x of 3 is 1. That's 1 times 1. So if you should put this together, we are going to be having 4 plus 3 plus 2 plus 1. And that should give us 4 plus 3, that's 10, 7, 9, 10. That will give us 10. So now we've gotten our x of 0. So the next thing now is we are going to x of 1. That means when k, so let me just change the color. So now when k is equals to 1, so we are going to repeat the same thing, although we are going to get some different value. So that means x of 1. Are we good? So x of 1, that would be x of 0 exponential. So now that means, let's go back to the, okay, so that will be x of 1. So we are going to be making reference to this x of k. So that's x of 0 exponential minus j plus x of 1. So now at this point now that our k, we already know that for our k is 1. So if you should put it 1 here, we are going to be having exponential minus 90 degrees. Exactly. Since our k is 1. The reason, because unlike here, when our k was 0, that's why we just have exponential minus j. But now that our k is 1, so that's minus j, then 1 multiplied by that 90 degrees. I hope that is clear. So that will be exponential minus j 90 plus x of 2. So for x of 2 now, already I have our k to be 1, so that will be minus j180. j180 degrees plus x of 3 exponential minus j, k is 1, so this is it here. So if since k is 1 at that point, that's minus j 270. Alright, so let's tidy this up. So don't forget our x of our x of 0 is 4, so that will be 4. 4 times exponential minus j is 1. Then plus x of 1 is 3. Okay, I think I omitted exponential here. There should be exponential, and here too. Alright, so for us to get the value of what this exponential minus j 90 degree will give us, so let me just put that somewhere here. Let me just explain that somewhere here. So for you to get that, just take note of this. You are going to be applying cos theta minus j sin theta. Exactly, take note of this. So now let me just open my calculator and show you how you can just simplify this guys over here. Alright, so just get your calculator now. So just take note of this formula like I said earlier. Now the angle we are making reference to now is 90 degrees. So let me show you how to do it. So just head over to your calculator. So let me just start all over again. So you come in and type in cos, and then the angle you want to use that you are making reference, that's 90, close the bracket, minus. Now for you to get that j, just come on your calculator and then press shift. So where you are having this eng, shift and then you press the eng, you'll be having this I. So the I is also the same thing as the j. Then you type in your sin 90. That's sin 90. Okay. So you can see it's already giving us the answer as minus I. So that minus I is just like minus j. So let's go back to our workbook. Okay, so that means this exponential minus j90 is what is actually, okay, so it's actually times minus j. So with that, we've been able to simplify this particular one. So now let's continue. So let's continue here. So then plus, now x of 2, our x of 2 is 2. So that will be 2 times. Now the same thing we are going to do here, we are having exponential minus j 180 degrees. So let's go back to our calculator. Now instead of 90 degrees, we are working with 180. So let me go back to the calculator. So let me just change the 90 to 180. So you can see that is giving us minus 1. So let's go back. So that's the value. So that's 2 times minus 1. Then plus our x of 3. X of 3 is 1. So that will be 1 times. Now exponential minus j 270 degrees. So let's go back again to our calculator. So let's change the 180 to 270. So that's giving us I. So that I is just j. So since we are using j here. Alright, so now let's simplify this. Now 4 times 1 is 4. Then plus 3 times minus j, that will give us minus 3. So and then the plus here, so it will still be minus 3j. Then plus, so 2 times minus 1, that will give us minus 2. Then, so plus 1 times j, that will give plus j. So this can also be written as, we're having 4 and 2, 4 minus 2, that will be 2. Minus 3j plus j, that will give us minus 2j. So this is the DFT value as for x of 1. Exactly, the first one we got 10, we got 2 here. So now we are going to continue again for x. So let's just change this. Now we are dealing with x of 3. That's when x is equals to, is it 3 or 2? Okay, 1. So now we are dealing with 2. So let's continue. So what we are going to do now is from here again, we are going to replace this k with 3, and then we repeat the same process we did for x of 1. Alright, so that's equals to x of 0 exponential minus j plus x of 1 exponential minus j. So let's go and put in the value of k to be 2. So right here, if the k here is 2, that means we're going to be having exponential minus j 180. I hope you are getting the concept now. Exponential minus j 180 plus x of 2 exponential minus j. So let's go and check s of 2. So this is going to be 360 because our k now is 2. So that will be 2 times 180, that's 360. Minus j 360 degrees. So don't forget the degrees. Plus x of 3 exponential minus j. So for that x of 3, so that will be 270 times 3. This is it here. Because now our k is, okay, sorry, our k is 2, not 3. So that's 270 times 2, that was 540. Minus j 540. So now let's clean it up. X of 0 is 4 times exponential minus j, we've established that to be 1, plus x of 1 is 3 times exponential minus j 180. I think we've gotten that before. Now this is it, yes. So we've used it earlier. Minus j 180, and we got it to be minus 1. So there's no need to go back to the calculator. You can just copy value. So for 360, we've not had the value for 360. So, but x of 2, our x of 2 is 2. So that will be 2 times. So let's go and check what's the value of exponential minus j 360. So we'll replace 270 we are having on the calculator with 360. So that's giving us 1. So let's put in the value, multiply by 1. Then plus x of 3. X of 3 is 1. So don't forget the x of 0, x of 0, x of 1, x of 2, x of 3. These are values that we already given in the question. So that will be 1 times exponential minus j 540. So let's put in 540. 540. So the answer is minus 1. So that will be 1 times minus 1. So let's clean it up. So 4 times 1, that will be 4. Then plus, in this bracket we have 3 times minus 1. So that will be minus 3. Then plus 2. And then here we are having 1 times minus 1. Then plus 1. So that will just be minus 1. So if you should clean this up, we are going to be having 4 minus 3 plus 2 minus 1. And that will just give us 2. Very good. So let's look at the last one, which is x of 3. So if you are finding value in this, please give it a thumbs up. So for our x of 3 now, so what this actually means is that now we are going to be putting the value of k to be 3. So let's repeat the process again. So I hope you've gotten how to go about this. So now we are going to be having x of 0 exponential minus j. So this is more like constant because our n itself is already 0 here. So that's why this is more constant throughout. Plus x of 1 exponential minus j. So now let's go and put in the value of k to be equals to 3. So see, for k equals to 3 at x of 1. So let's see. So this is it. At x of 1, if k is 3, that will be 90 times 3. That's 270. Alright. So minus j 270 degrees plus x of 2 exponential minus j. So let's look at x of 2 if you replace k with 3. So x of 2, if k is 3, so x of 2, where is it? If k is 3, so that's 180 times 3. So 180 times 3, that's 540. Alright, so that will be minus j 540 degree plus x of 3 exponential minus j. So let's go and look at for x of 3. So this is for x of 3, that's k is now 3. That will be 270 times 3. So this is it here. 270 times 3. And that's going to give us 810. Okay, I hope you can see this. So that will be minus j 810 degrees. Alright, so now let's tidy it up. So again, x of 0 is 4. 4 times 1 plus our x of 1 is 3. So that will be 3 times exponential minus j 270. We've gotten that earlier. Let's see. Yes, we've gotten it here. And that gave us j. So don't need to go to the calculator. That will be times j. Okay, so plus. Now for this here, our x of 2, that will be 2 times minus exponential minus j 540 degrees. I also believe down this is it. We've gotten it here too to be minus 1. So that will be 2 times minus 1 plus x of 3. Our x of 3 is 1 times exponential minus j 180 degrees. So let's go back to our calculator and just put in 810 minus j 810 degrees. So that's giving us minus 1. Sorry, let me check it again. Sorry, that's minus I, not minus 1, minus I. So that minus I is minus j. So that's minus j. Okay, so this will be 4 times 1, that will be 4, plus 3 times j, that will give us plus 3j, then plus 2 times minus 1, that's minus 2, so that will give us minus 2, then plus 1 times minus j, that will give us minus j. So tidying this up, we have 4 here and minus 2, so that will give us 2, and then 3j minus j, that will give us plus 2j. So now we can conclude that our x, remember the question says, let's go back to the initial question itself. It says compute its DFT, that's x of k. So if you had to compute our DFT, so we can just conclude that our x is equals to 10. That means when it was x of 0. So when it was x of 0, we got the answer to be 10. When it was x of 1, we got the answer to be 2 minus 2j. So that will be 10. 2 minus 2j. Then when it was x of 2, we got the answer to be 2. So let's take note of that. That will be 2. And then when it was x of 3, we got it to be 2 plus 2j. So that's 2 plus 2j. And what we have right here is our final answer. And so this is how you go ahead to apply the formula for DFT to calculate questions like this on DFT. Exactly. So for the B and the C part, I'll be doing that in another video, so that the video will not be too long. So I hope you find value in this. If you have any question or any doubts, do not hesitate to leave them in the comment section. And if you are yet to subscribe, please kindly click on that subscribe button. And if you missed the previous part of this lecture series, kindly check the playlist on signals and system. You'll find the link to all of those videos. So with that, I'll see you all in the next part where you're going to solve the remaining parts of this question. Exactly. So thank you very much, and bye for now.